This is KBYP with a video on the Drake TR3 and TR4 sideband filters, their history, their design, etc., etc. There's a TR3 in belly flop mode, doing surgery on the redesigned sideband filter. Smaller, faster, lighter, cheaper, and orders of magnitude better than the old soup can. That's the guts in the soup can. 8 big honkin' HC6 high resistance lossy crystals that suffer severe frequency drift, and it's not a defective crystal blank that does it. There's something else weird happening. And the soup can, what it came in, and the similar but significantly improved TR-4 filter from 1975. Network Sciences, Inc. Myth. The Drake filters are lattice filters. Absolutely false. Persons making this statement know nothing about this. I have absolutely thoroughly reverse engineered these filters and copied them, and my copies work just dandy. So, not lattice filters. The schematic of this TR4 filter might appear to be a lattice, but it is not. Drake documentation TR4, the statement, the sideband filter has attenuation, or I forget the word they used, like an 8-pole filter, but it is not. These filters hearken from a design patented back in the 1930s, and yes, I have that thoroughly researched this, called a neutralized design, as in a similar term with a neutralized amplifier. And that is essentially use reactants to bring the crystal to tune. The TR3 filter was made with HC6 crystals, very lossy, high internal resistance. The TR4 version with HC49 holder crystals and still inferior, because even the HC49s, some of the better ones today, are spec'd upwards of 60 ohms ESR. And that is way too high for a filter. The impedance in circuit of this filter network system is somewhere in the order of 40 to 120 ohms. So 60 ohms is not going to work. HC6 crystals had lower resistance, but these are old crystals. The modern replacements I bought I've measured several at 6 to 9 ohms ESR. And about 3¼ picofarad. Almost perfect. The failure in these filters is not that the crystal breaks necessarily, but a process they used back in the day to tune these, which is chemical, not mechanical, goes astray. And due to heat under the chassis, due to Drake foolishly putting high-powered resistors under the chassis right beside the filters, caused the crystals to drift off frequency a lot. And that's the end of the filter. It's possible to correct that. I'm not going to bother with telling you how. My little secret. It's possible to fix that. I wouldn't bother, because you still have inferior crystals with high ESR. TR3 and 4 sideband filter, neutralized design, not lattice filter. Just because a schematic of a lattice has an impedance arm that goes diagonal from end to end, and just because that filter has components that go diagonally does not make it a lattice filter. Because the diagonal path must be a signal path, and it isn't in that filter. This is the basic design of both. Transformer on the left and right, input, output, or output, input, depending on transmit or receive direction. Other side of each transformer is a plate of a tube. On one end, V15 balanced modulator amp. On the other end, plate of a mixer. This is an impedance inversion design. From the left, secondary of a transformer, oversimplified, through a crystal to a capacitor. That capacitor causes an impedance inversion, so that when it comes to the transformer on the right side, it becomes a resistive value. And that's how the filter system becomes a resistive transfer function. It's because of that capacitor. In the TR4, there are crystals down here along the bottom, 2 2, 2, and 2, 8 crystals instead of 4. So that is roughly what's going on here. It is absolutely impossible to take these filters out of the system and test them separately and expect to get a passband. You will not do it. It will appear in a frequency sweep as several spikes that don't make any sense. This filter cannot and does not work by itself. It must have the plates of the tubes on each end and the transformers to tune this system to a resistive transfer. No one will take a lattice filter and plug it in here and make it work. I know 2 engineers that thought they were going to do that, and they both failed. The 3rd engineer I know didn't fall for it, and that's me, because I studied the design first, and I know that won't work. These filters are a complex impedance at each end without the transformer and the tube plate circuit. Complicated setup. Again, you will not, I repeat, will not ever take these filters out and put an impedance analyzer on them and get a filter passband. Absolutely will not. Don't even bother. So go try it anyway. Hi. Since and therefore and all that, the lattice filter will not work in this circuit. Since ICM's out of business, I can't get any more of these HC6 crystals. They made, I think it's a 2 on top there for me, replacements for $26 a piece. I went through significant pain and almost $1,000 to get brand new, absolutely state-of-the-art crystals out of a foreign country. And there's the tiny replacement for these mongoloids with absolutely superior crystals, 6 to 9 ohms on a couple I measured. That's essentially 0 loss. And boy, does it show in the performance. The Drake design is 2 filters and 1 carrier. That has the advantage that when bands are changed and filters are swapped, that the VFO setting stays about the same. For simplicity, low cost, etc., I decided to go with 1 filter and 2 carriers. That has a disadvantage of going to the opposite sideband, requires changing the tuning about the width of the passband of the filter, which is a little bit over 2 kc. Not a crisis, because this is a mechanical VFO and it requires constantly checking and calibrating it against the marker oscillator anyway. But the advantage is that with 2 carriers, each can be set independently with the response of the skirts on the filter, and they are not quite symmetrical. To exaggerate the response, maybe it's something like that. Sharper on the lower frequency on the left, broader rolling off on the right. So that allows the upper crystal, the higher frequency crystal, to be moved with regard to that sloping passband to get either whatever tone response you want in sideband, or to get full carrier drive for full power output on CW. Because if the carriers move too far away, the 9 megahertz approximately carrier signal into the mixer will be weak and won't get full drive to the PA stage. So power output will suffer. These crystals are at about 9 megahertz, plus or minus an offset of about 400 up to about 23 or 400. I moved those a little bit, partly by design, partly by accident, especially because new crystals are so superior and stronger that I had, with new carrier crystals, I had plenty of carrier output, such that I could do away with the switched carrier frequency that is necessary for the Drake TR3 and TR4. In these rigs for CW, instead of in sideband, where the carrier would be down here out of the passband, in CW, especially in the TR3, the carrier had to be shifted up about a kc up here into the passband to get full output. That has some problems. My redesign uses an RIT, that board, which was an absolute nightmare to design and interface with that high impedance VFO. But instead of jumping the carrier for the CW offset and having the CW tone always be a dog whistle pitch of about a kc. This way the carrier's fixed. I turn the RIT off, tune to the sending station 0 beat, flip the RIT on, and shift to any tone I want. Oh, that works beautifully, because I can also vary it to move the signal being received into one of the peaks at either edge of the filter response, in a manner such as that, little lines pointing to the peaks in the filter response. So I can tune the desired signal to one of those peaks and get about a 3 dB rejection between that and interfering signals, and it's basically a free CW filter. It ain't 20 dB, but it doesn't cost anything. So I can not only set the tone I want to hear to anything I want without the other station knowing it, but I can also peak it. So that's roughly like adding CW filters to the rig, and very useful. Here's a new filter assembly for the TR3. Instead of having a single filter unit with long pieces of triacs, the transformers in the TR3 are center tapped. It's not shown in that schematic there. That's kind of what the TR4 filter looks like, but in the 3 it's center tapped. And a center tap is a common, and those black cables are not shielded coax, they're triacs, unshielded. So to do away with that, I put each side of the crystal assembly at each transformer with short lead wires, and ran a piece of shielded RG174 across. Should give better rejection of stray RF. The filter is a rather low impedance, on the order of 50 to 100 ohms, but still it's pretty sensitive, so it needs to be shielded. And I didn't like the idea of that almost a foot of triacs running unshielded across the chassis. Just a recipe for picking up trash. But those are absolutely state-of-the-art crystals from a major crystal manufacturer. These were bought directly from a manufacturer, not through a distributor in the U.S. that buys them from a manufacturer in China. I took one apart. It is jaw-dropping, the quality. Very wide metallization, beveled blanks, short, wide straps instead of wires to lower the inductance. They're just unbelievable quality. And you would fall out of your chair if you knew what I paid for each one of those on a per crystal basis. It was, I mean, you're looking at a filter that cost me almost $1,000 to build because I had to buy some quantity. But fortunately, I found a manufacturer that was willing to work with me. And they had never made those crystals before. I mean, nobody's doing 9 megahertz now. So they were kind enough to do that, and I sure do appreciate it. But the later filters may have gone to 5-some megahertz. They might be lattice filters, but these are not lattice filters. Not, regardless of what any self-absorbed Drake expert tells you. They are not. And as far as I know, Network Sciences and me are the only ones that have ever reverse engineered these. Well, they've forward engineered them. But I don't think anybody else out there knows anything about them. And it's very, very likely that if you buy a TR3 that this filter's bad. And quite possible in the 4. And if they are, the radio's toast. It'll work on CW and AM, but not sideband. So it is a serious problem to have these filters defective. Apparently they can be replaced for 130 some bucks plus tax, postage, shipping, whatever. But I don't know if anybody's still making them anymore. Last time I looked, there were ads for it, but I don't know. I didn't get any responses on asking to buy them. So I have extra crystals of these. Anybody needs a set, contact me. Email address in the video description. So KBYP did that.